Hello everyone. Today I'm gonna to talk about a very interesting topic in geotechnical engineering. It's about calcium carbonate precipitation by using plant ureas for soil improvement. This is Ahmed Miftah. So the outline it will be about I will talk about the geotechnical engineering. What is geotechnical engineering? What Icp treatment, enzymatic induced calcite precipitation mechanisms, and potential application, and I will also talk about a laboratory study that I have done in CIU Geotechnical Laboratory under the supervision of Dr. Ria Benson and Dr. Hamid as well from Arizona State. In general, what is biogeotechnical engineering? It is a novel geotechnical branch and that's aimed to develop or introduce bio-based process and product in order to find more sustainable and eco-friendly method to mitigate the impact of civil engineering activities and geotechnical engineering activities on the environment. That's according to Harvard University. So what's the Icp treatment in general? According to chemically basically, so it is precipitating calcium carbonate using urea use enzyme, which is found in many plants, seeds like jack beans, soya beans, terminal beans, and many. So the ureas where hydrolyzes the urea in the presence of calcium ion source, and that's energy lead to find the favor to precipitate calcium carbonate. Geotechnically, if we applied or penetrate this EICB solution to the soil, what will happen will lead to precipitate the calcium carbonate between the soil particles and leads to a reduction in permeability and enhancing its strength and filling the pores and increase also the interlocking bounding between the sand particles or soil particles, and as a result will increase also the strength of the soil. So in general, what is EICB solution? What is enzymatic induced calcite precipitation solution that you are using in general, and how to apply? Simply, it's containing for three components, mainly the main components: urea, calcium sources. In our case, we are using calcium chloride, and ureas and milk powder. So we are using milk powder as stabilizer. So, and we have done a study to measure what is the effect of adding milk powder. In many studies, they have reported that it will be it's used as stabilizer. So in our case, we found that after adding the milk powder, we have increased the precipitation efficiency more than 40%. So after mixing this component together, and for maybe one minute or less, so we will apply this to the soil. For example, if we have loose sand, so this is good to start the precipitation between the sand particles, and finally we can get this cemented beach sand columns. So this sample has prepared in the geotechnical laboratory in CIU University. So that's in general. There are many application methods by oleography or by mixing and compact, and also you can use BUM, static BUM, in order to apply pressure during the application. And this is the mechanism of improvement. Let's say that. So if we apply different cycle, this is one cycle, two cycle, three cycles. After the first cycle, as we can see, this is the red small circle represent the calcite. So after increasing the cycles, we will increase the precipitation rate, and as a result, we'll enhance the strength of the soil and increase the also the and also to decrease the permeability of the soil. So with the increasing the number of cycle will increase the precipitation, calcium carbonate precipitation rate, and as a result, we will increase the enhancement at the same time. What's the meaning of, for example, if we need to apply 1 cycles, we have used 70 milli. So the second cycle, after 4 days, we will apply the second cycle with 70 milli at the same time, and the third cycle, it will be same of EICP solution. What's the potential applications? As we know, many researchers around the world, they have reported and they have introduced this method for many applications, for example, liquefaction, also for dust control, coastal erosion, as in our case, we have introduced it for Cyprus case, and more and more. So there are many, the area still is open and still quite new. So there are many applications that we can use in that, using this EICP technology. So this is our study. Actually, that's part of our study, applicability of using EICP to mitigate the coastal erosion in Cyprus. What we did, we take samples from Cyprus beaches from Augusta Bay, this beach, and we have done a study to understand what is the effect of using this and what is the applicability of using EICP to mitigate the coastal erosion in Cyprus, because it is very critical according to EU reports about 2009 about the erosion. It's increasing every day. So we have evaluated this method using mini-jet erosion tests, and that's the first time that's done for Icp treatment to measure the erosion. So we have evaluated the surface erosion resistance and scar as well. As we know, the scar also are very critical issue, especially related to the bridge engineering as well, and also all infrastructure projects and applications will be very effective method. This is the sample, our sand soil specification. And as we know here, this is the mini-jet erosion. It was according to Ahmad. So what Ahmad did, actually it was a field test. So he has transformed him to modify it to be more usable in the lab applications. So we have built this in our lab in CIU. As you can see, this constant head tank. This is the chamber where we put our samples here. This is the nozzle. So we'll apply different pressures. We will apply the pressure here and we get the jet. So this is our outline house. So we will measure after, we will measure the depth leading gauge, the depth reading gauge with the time. So this is the model they have used to measure the erosion rate. It is based in durability, behavior or parameter of the soil. So ER, it is, we found this solution from 1990 to measure the erosion rate of the soil. So ER is the erosion, KD is the durability coefficient, tau is the maximum shear stresses generated from the jet velocity, and tau C, it is the critical shear stresses where they reach to equilibrium. In general, because it is very difficult to reach the equilibrium at the critical shear stresses. So what they did, they have built a model, a linear mathematical model, because they found that it's need maybe 1 year just to reach to the equilibrium. steady state. So they built that model using the Excel sheet program. I have contacted Dr. Fox from North Carolina University, and they have sent me this program, and they also told me they will send me another one, the updated one, maybe by the end of this year after finishing their work. So this sample before and after. This is 1 cycle, 2 cycle, and 3 cycle of treatment. This is before and after. It is very clear that this is the calcite, the layer on the top of the soil. After the applying the erosion, it starts to be eroding. So after the increasing the eroding, it's become area, it's on the scar only in the middle where we have applied leisure. For the first cycle, it's totally eroded from all the sides. So let's see the result. This is our calculations for control 1 cycle, 2 cycle, and 3 cycle. So after 1 cycle, the erosion rate, it was about 31 in average. And after 3 cycle, it was 0.36. We found a very huge improvement, about 71 times. So even after the 1 cycle of the treatment, we get a good result. We get 1.14 as well. So according to Simon, what happened after applying? So we wasn't able to add the control sample because it was the KD. It was very, very high because it's very readable. So the erosion will be very high. Because as a logic, it is a loose sand. So this is very readable after 1 cycle, very readable after 2 cycle, and we have transformed to moderate resistance. So after the 3 cycle, we get a good result. Even they are very close, similar between 2 and 3 cycles. So with the increasing with the number of cycles will increase the resistance of erosion. This is that's classification according to Simon 2001. And finally, we'll talk about the scar depths. With time, as you can see, this is for pure sand. It is finally because the depth of the depth of the sample, it was 8, so it's totally reached to the maximum after maybe 30 seconds. All the sample it out. So with the increasing this 1 cycle, 2 cycle, 3 cycle, we will increase the scar resistance as well. So even for scar mitigation, so it will be a very, very good method also. So this is the same result of the sample before and after. This is a pure sample, our pure lovely samples. This red arrow, it represents the calcite on the surface. This is between the samples, between the sand particles, and this is on the surface. So this will increase the roughness of the samples, and will increase the interlocking between sand particles, and as a result will improve the geotechnical and hydraulic behavior of the sand. So this is biocementation, pure, and for biocemented, there is no any different. We get calcite cases. So finally, we have concluded that this method are very useful for erosion mitigations in Cyprus case. We need to conduct more field testing. So this the laboratory has confirmed this method. So now we should have a field study in order to confirm between the laboratory and the field study. Finally, these are our references, and thank you for your attention.